Welcome back, and we will continue another vision into what the standard deviation is and how it can be used in interpreting a datum point to let us know its location around the mean. What if I just walked up to you and said 150? 150 is a raw data point, and that value could be a good point, it could be close to the mean, it could be far from the mean. It really doesn't mean anything when you just say 150. If you were taking an IQ test and the average was 100, 150 might be good. If you were taking an IQ test and the average was 300, then 150 might not be good. That's a raw data point, and as a datum, it just gives a raw value, which really doesn't mean anything. What we're going to do is we're going to get information, and 150 with no other information would just be meaningless. With descriptive information, 150 can be interpreted relative to the population or sample mean, and then it begins to make some sense. Consider the following. Let us interpret 150 where mu, or the population mean, is 100 and the standard deviation is 20. What that means is that the mean is 100, the standard deviation is 20, and 150 is way out here, at least 2.5 standard deviations above the mean. When we talk about how many standard deviations a data point is from above or below the mean, we're talking about a z-score, and which is a new term for us. If x is 150 and the standard deviation of 150 tells us that it's 2.5 standard deviations above the mean. That's very relevant information. This raw data point, if we talk about it, how many standard deviations it is above or below the mean, gives us a real clear understanding of where that data point lies in the distribution. This value is called a z-score. How many standard deviations a data point is above or below the mean. Describing 150 relative to mu and sigma is called a z-score. And z of 150 is 2.5. A z-score is a way of expressing the location of a datum in light of mu and sigma to allow interpretation of the data's location in the population. Now you know everything. That really wasn't very hard, was it? Let's go back and look at it again. If we have 150 and we just have a raw value 150, it doesn't mean anything to us. But if we can say that it has a z-score of 2.5, that means its location is 2.5 standard deviations above the mean. If it had a z-score of negative 2.5, that means it's 2.5 standard deviations below the mean. You're meeting a new value, which is called the z-score. Again, that's a way of expressing the location of a datum in light of the mean and the standard deviation. I point out to you in this example, I used a population, mu and sigma, the mean of the population and the standard deviation of the population. In most cases, we will be using a sample in which we will use X bar and S to tell us what z-score a data has, so we can interpret some things about the population, or we can infer some things about the population. Keep climbing the ladder. You're getting this one step at a time. You're doing well. You're going to survive.